Hi, this is SHSAT Mathematics Lesson 7. In this lesson, we will learn about prime numbers, even and odd integers, positive and negative integers, factors and multiples, GCF and LCM. What is the sum of all distinct prime numbers of 323? So if you think about it, 323 is a number much smaller than 400. Notice that 20 times 20 gives 400, so at least one of the factors of 323 must be smaller than 20. So if we think about the prime factors that come before 20, we have 3, 7, 11, 13, and 17, and 19. So these must be a factor of 323. At least one of them must be. So if you divide 323 by these factors given above, you would see which of these would be divisible into 323. So if you divide 323 divided by 17, you would get 19, and that would tell us our number. So we know that 323 is divisible by 17 and 19, and they are both prime numbers because they are no longer divisible by any other number besides itself and 1. And so if we add them up, you will get 36. So these are our distinct prime numbers, and so we have this. So the sum of all the distinct prime numbers of 323 is 36. How many distinct pairs of the first 5 prime numbers have an odd product? So the first 5 prime numbers in the set is 2, 3, 5, 7, and 11. The product of the two odd numbers is an odd number. So the possible pairs are 3 times 5, 3 times 7, 3 times 11, 5 times 7, 5 times 11, and 7 times 11. We did not include 2 because 2 is an even number. So 6 distinct pairs of the first 5 prime numbers have an odd product. So these are the distinct pairs. The sum of all digits of a number is 273. The number is always divisible by which prime number? If the sum of all digits of a number is divisible by 3, the number is also divisible by 3. So if you divide 273 by 3, you have a 91. So that means the original number is divisible by 3. An example of to see if a number is divisible by 3 is like 348. So if you add 3 plus 4 plus 8, that gives us 15. So 15 is a multiple of 3, and if you divide it, you get 5. So 348 is divisible by 3. So the answer to this question, the number that is always divisible by which prime number? The answer is 3. So what is the smallest integer that is the sum of 3 different prime numbers greater than 81? So you want to look at the numbers that are greater than 81. So you start with 81, and 81 is a multiple of the 9 times table, so you know it's not prime. 82 is even. 83, you can check by adding the digits to see if it's divisible by 3. 8 plus 3 is 11, so it's not divisible by 3. This is also not a multiple of the 7 times table, which you can check by thinking of 7 times 10, which is 70. You have 77, 84, and 84 is greater than this, so it's not divisible by 7 either. So this is actually our first prime number. So you continue 84. 84 is even, so you won't be a prime number. 85, divisible 5. 86 even. 87. This you want to check, divide by if it's divisible by 3. If you add that, you get 15. So it is a factor of multiple of 3, so not prime. 88 even, not prime. 89, you want to check. So 89, if you add that up, you get 17, which is not a multiple of 3. And you also want to see if it's divisible by 7. You can check this. 84 plus 7 is 91. So 89 is not a multiple of 7 either. So this is our second prime number, 89. And you continue on. 90, even. 91, you want to see if it's divisible by 3 or 7. Well, you notice if I wrote 91 here because 91 is a multiple of 7. So this is also not prime. So you continue on. 92, even. 93, if you add that up, you get 12. So it is a multiple of 3, not even. 94, even. So now prime. 95, multiple of 5. 96, even. 97, you check, you get 16 if you add the digits, not a multiple of 3. 98 is the next number in the 7 times table, so 97 must be also a prime number, and that is our third prime number. So we have 83 plus 89 plus 97, and if you add that up, you will get 269. So that is our answer. A and B are positive integers, and AB plus A is odd. Reina concluded that A and B must be odd. Is she correct? So our rules for dealing with odd and even numbers, so odd plus odd is even, odd plus even is odd, even plus even is odd, as even plus even is even. As AB plus A is odd, AB or A, one of them must be odd. Again, and we also have a multiplication of AB, so if you think of our odd and even multiplication rules, odd times odd is odd, even times even is even, and odd times even is even. So if A is even, AB is also even. Because if we have an even A, B, no matter what you multiply an even number with, it will also always result in even, because 2 times 3, even times odd, that will give us 6, and 2 times 4, even times even, still gives us an even number. So if A is even and AB is also even, AB plus A is even, because you have here even and another even, and even plus even is even. And if A is odd and B is odd, then AB plus A is even, because if you have AB as an odd number, 3 times 3, let's say, and that would give us 9, which is odd, and odd plus an even number, or an odd number in this case, would give us even. So because odd plus odd gives us even. And therefore AB plus A, to be odd, A must be odd and B must be even, because A, if it's odd, B, and if it's even, that would give us even. And if A is odd, then if you have AB, which gives the product to us an even, that would give us, let's say if we have A as even, that would give us an even answer. So Reina is therefore incorrect, because A must be odd and B must be even. So set A contains all positive odd numbers, set B contains all factors of 33, set C contains all prime numbers. How many numbers belong to all three sets? Set A contains all positive odd numbers, set B contains all factors of 33, set 3 contains all prime numbers. How many numbers belong to all three sets? So the explanation here, we have set A, set B, and set C. So you're trying to figure out which numbers belong to all three sets. So if you look at the smallest set, it'll make it easier for you, because you know there's easier to find numbers in there that will be common in all sets. So set B has the smallest because it's all factors of 33, so it's 4 digits. And so if you look at A and C, you just look at the rules that A and C has to see if any numbers from here will also be in A and C. So A is all positive odd numbers, so we have all positive odd numbers here, so we know all of this will go into A. C has all prime numbers, so we have to see if this is all prime numbers. So 1 is not a prime number because 1 cannot be a prime number. 33 is not a prime number either, because you have 33 has multiples of factors, like 33 and 1 and 11 times 3. And 3 and 11 are prime numbers because it doesn't have any other factors besides itself and 1. So 3 and 11 are the prime odd numbers and factors of 33. So those two numbers are the numbers that belong in all three sets. So this question is asking which of these multiple choices will give us an odd result. So odd, this is addition and subtraction we're dealing with. So odd is resulted from odd plus even gives us odd. Take a moment and pause this video and see if you can get that. Take a moment and pause this video and see if you can get that answer for this question. So the question asks is, for any integer m, which of the following must be odd? Justify your answer. So if we want odd as our result when we're dealing with subtraction and addition, odd plus even is what gives us odd. So since this is dealing with addition and subtraction, we will look at each of the problems. A, so we have an odd number here and we have an odd number here, which is part of a multiplication. So we want to see if this multiplication can become an even. So 3 times m. So 3, and which is an odd number, odd times odd gives us odd, and odd times even gives us even. So we want to see if how this number, this product can be even. But we have no way of knowing if this is going to be even or odd, so this must not be the answer. And that's the same case for B, because we have an odd number here and we have no way of knowing if this is going to give us even or odd, because 7 is odd and odd times even or odd will give us different answers. So it's not B. And 9m plus 6, so this is even, so we can try to see if this number can be odd. But once again, odd times odd can also give us odd, and odd times even can also give us even. So if we by chance have even plus even, that will not give us odd, so it can't be C. And D, so we have an odd digit here. Here, in this case, we have a even as our factor. So 2 times m. So even times even will give us even, and we know even times odd will also give us even. So even, whenever multiplied by anything, will always give you even. So we know that this is going to give us, this product is going to be even as well. So even plus odd. So we now have that case of odd plus even. So we know D is our answer. The sum of 6 different positive integers is 90. If the smallest of these integers is 10, what is the largest possible value of the integers? So the sum of all 6 of the different positive integers is 90, and the smallest one is 10. So if one of the integers is the largest, the other must be the smallest. So the smallest, we can pick the smallest 5 integers possible. Since they told us the smallest is 10, we can pick 4 others that would be slightly bigger than 10, but smaller than like the smallest possible. So 11, 12, 13, and 14 is the 5. And so the sum of the smallest 5 is 60. And so if we have 60 and we know that all 6 is going to add up to 90, we subtract the 60 and that gives us 30. So we know this is the largest possible integer. If the product of the integers p, q, and r is 1, what is the smallest possible value of the sum of p, q, and r? So if you multiply p, q, r, we should have 1. So the only way possible for us to get 1 is like if we multiply 1, all of these are 1 but different. So we have 1 times -1 times -1, that would still give us 1 because we want it to be the smallest possible. So negative numbers are smaller than positive numbers, so a negative number is smaller than a positive number of 1. And if you multiply -1 times -1, that still gives us a positive 1, so we end up with the product of 1. And the reason why one of them had to be positive is because if you multiply -1 times -1 times -1, this will give us a positive 1, but if we multiply with another -1, we will get negative again. So that's not the product we want. So our answer for us to have a positive 1, we have 1 plus -1 plus -1, and that's how we get our answer of this. So, and if you add them up, you will get -1 because multiplication rules of negative and positive is different from the addition subtraction rules. So if you add two negatives, you'll still get a negative result, and here we have -2, and then we have the 1 plus. So if we would 1 plus -2, that will give us a -1. So the smallest possible value of the sum of P, Q, and R is -1. Take a moment and pause this video to see if you can get this answer for that question. So it asks, is the product of 6 consecutive even integers is 0? So what is the least possible value of these integers? So we know the only way we can get a product of 0 is if 0 is in the integers, and it Take a moment and pause the video to see if you can get this answer for this question. So this question asks, is the product of 6 consecutive even integers is 0? What is the smallest possible value of these integers? So since the product we have, it must be 0. Any number multiplied by 0 will give us a 0. So we know that no matter what the numbers they are, it's still going to be 0 if you're multiplying 0 with it. So now we have to figure out the other numbers that are even, consecutive even numbers. So what's the smallest possible value of these integers? So we know that negative numbers are smaller than positive numbers. So we know these numbers, if they're the smallest possible, it should be negative. So we will have this most likely. So we have 2, 4, 6, 8, and 10, all of which are negative. And that gives us 6 of our consecutive even integers that are, when you multiply, give them 0. And they're asking what is the smallest possible value of these integers. So they mean they're asking for the smallest value in there. So the smallest value, it has to be -10 because a number that's the most negative is the smallest. So the answer is -10 we have right here. When k is divided by 4 and the remainder is 2, what is the remainder when 3k minus 1 is divided by 4? So when k is divided by 4, the remainder is 2 we have. So that must mean k minus 2 is divisible by 4 because the -2 is like the remainder that we got. So if that was in k, so if that -2, that -2 isn't in k, it would be completely divisible by 4. So, and that means if we multiply this by another number, it would still be divisible by 4. So we want to see what is the remainder when 3k minus 1 is divided by 4. So we can try to make this expression as closer to this expression right here. So we want to multiply k minus 2 by 3, and so that it would still be divisible by 4. And so whenever we have a number outside of a parentheses and we multiply it, it will go into both. So that gives us 3k minus 6. So that's close to 3k minus 1. But we want it exactly like that. So we want to simplify it so that it's closest to that. So we can take away the 4 by doing the opposite by adding 4 from both sides. And that makes us this. So 3k minus 6 plus 4 gives us 3k minus 2, which is still divisible by 4 because if you add by a multiple of 4, or it would still be divisible by 4. So now we have 3k minus 2, and the way to make 3k minus 2 into 3k minus 1, we would add plus 1 because that's the way we make it into 3k minus 1, because minus 2 plus 1 would give us minus 1. And so that means, like, since this is divisible by 4, and we added the 1 in order to make it into 3k minus 1, that means 3k minus 1 must give a remainder of 1 when it is divided by 4. When an integer n is divided by 6, the remainder is 2. So when n is divided by 7, the remainder is 3. If n is greater than 50 but less than 90, what is the possible value of n? So they gave us 6, and that would give us a remainder of 2. And when n is divided by 7, that gave us a remainder of 3. So we want to know if n is greater than 50 but less than 90, what is the possible value? So you think about the multiples of 6 and 7. So the multiple of 6, we have it written down right here, and the multiple of 7, we have it written down right here. But in this case, they included remainders. So in order to figure out what is the value for n, which includes the remainders, we add the remainders to the multiples. So we have plus 2, so we added 2 to all of the multiples of 6 between 50 and 90. And same thing for 7, but 3. So we added 3 to all the multiples of 7 between 50 and 90. And so now we want to find the number that is common here between these two. So we look here, so these aren't common, but we have the 80, which is common. So 80 is the only possible value, so n must be 80. This question asks us, when m is divided by 7, the remainder is 2. What is the remainder when 4m minus 3 is divided by 7? So take a moment and pause this video and see if you can get that answer for this question. So I'm going to show you how you would do this question. So when m is divided by 4, the remainder is 2. So that means that if you have m minus 2, that would give us the value that is divisible by 7. So this m minus 2 is divisible by 7. So now we want to make this expression closer to this expression, so we can multiply m minus 2 by 4. And since we know m minus 2 is divisible by 7, this should also be divisible by 7, since when you multiply, it doesn't change the divisibility of 7. So now that would give us 4m minus 8. And so that's close to 4m minus 3. So we want to make, 4m is there, but we have a negative 8, so we want to make that into a negative 3. And the way we can do that is by adding 5. So we have 4m plus 5. And minus 8 plus 5 would give us negative 3. So we bring down the 4m down, and that gives us here. So this indicates that you would get a remainder of 5 when 4m minus 3 is divided by 7. So the answer is 5. What is the greatest common factor of 420 and 1290? So in order to find greatest common factor, we're using prime factorization here. So prime factorization, you would break it down into its smallest prime factors. And in order to figure out the greatest common factor, you search for common factors between these two prime factorization sets. So there's a 2 in both, 1 2 in both, and 1 3 in both, and 5 there. And the other ones that are not common, you would leave that out. And so you have 2 times 3 times 5, and if you multiply that, that will give you the greatest common factor that they would have. What is the greatest common factor of 12, 18, and 42? Take a moment and pause this video and see if you can get that answer. So you would take 12, 18, and 42, you put it down into its prime factors. You circle your prime numbers in there. And now you want to find which of these are common in all of them. So you see that there's 1 3 in all of them. Some have more than 1 3, but all of them has at least 1 3. So 3 is one factor, and all of them has a 2, So 2 is a factor. And the ones that are not common, you can't pick those. So, and you have 3 times 2 is would give you the greatest common factor. And when you multiply, you get 6. So your answer is 6. What is the least common multiple of 6, 9, and 18? So in order to find least common multiple, there's multiple ways to do it. But we're going to use prime factorization, and the way you do that, so you write out the prime factors of all of these numbers. And so what you do is you find the number that in all of them, you have to pick all of the numbers from in the prime sets that occur. So you pick the 2 occurs in these two, but even if it doesn't occur in one of them, you can still pick it. So, and then the 3 occurs in all. And so how many numbers of 3 would you multiply with? So you pick the 3, you've picked the most number of the 3 that's found in one number. So one number 9, it has the most number of 3s. So you would pick 2 3s and 1 2. So you have 2 3s and 1 2, and you multiply that and you get 18. And that's how you find the least common multiple. What is the least common multiple of 6, 18, and 24? Take a moment, pause this video, and see if you can get that answer. So again, you write out the prime factors. So you have 3 and 2. For 18, you have 9 and 2, and then you break it down further. So circle all the prime numbers. And so you pick, so notice that they all have 3 and 2. So you pick the most number of 2s and 3s that's found the most in one of the numbers. So there's 1 3 in all of them, so it's 1 3. In this one there's 2 1s. I'm sorry, there's 1 2, 2 2s, and 3 2s here. So you would pick this as the 3 2s. So you would have, this would be how you would get your answer, and you will multiply that, and that should give you what is the least common multiple of 6, 18, and 24? So you write down the prime factors. So you pick the prime factors, so of course circle them so you're sure. So you pick the number, so it's going to be 2s and 3s. So, but how many 2s and how many 3s? So you pick 2s that are the most occurrent, and so you write out the prime factors. Circle the prime factors. So they're all 2s and 3s. So let's start off with 2. So you pick the amount of 2s that are the most in at least one of the numbers. So there's 3 2's here, 1 2 and 1 2 here, so you would pick the 3 2's. And for the same thing for 3, so there's 1 3 here, 2 3's here, and 1 3 here, so you would write 2 3's. So if you multiply all of that, that would give you 72. A straight stick will be used to measure a rod of exactly 1/18 feet, which is multiple of the size of the stick. The same stick will be used in the same way to measure another rod of exactly 5/46. What is the length of the longest stick that can be used for both measurements? So the maximum size of the sticks is the greatest common factor of both numbers. So you prime factorize it out. So you write out the prime factors of both numbers. And so you're going to look for the common numbers. So because it's greatest common factor, we are looking for just the commons. So they both have 2 and 3. So if you multiply 2 and 3, we get 6. So the longest length of the stick is 6 feet. The circumferences of 3 wheels are 12 inches and 16 inches and 20 inches. At point P is marked on 3 wheels. What is the greatest number of complete revolutions made by the smallest wheel when point P on each wheel comes to the starting position again for the first time? So we want to find the lowest common multiple, the least common multiple. So we have the factors written out. And so we have the multiples, the factors. So there's 2 2's here, there's 4 2's here, and there's 2 2's here. So we're going to pick the 4 2's as here as part of our way to get the least common multiples. So that's it. And they all have, this one has 3. Even if the other numbers doesn't have 3, we still pick that because it still has to go in with the common multiple. And then we have the 5's. So we have 2 to the 4 times 3 times 3, and you multiply all of that, and that gives you 240. So the greatest number of complete revolutions made by the smallest wheel, we would get by getting the greatest multiple and then dividing it by 12. So we would get 20. The floor measures 90 feet long and 74 feet long. What is the greatest side of square tiles that can be used to cover the floor without cutting any tile? So the greatest tile of the side must be the greatest factor, greatest common factor. So we write out the prime factors, and so they only have the common factor of 2, nothing else. So the greatest common factor is 2. So the greatest side of square tiles that can be used to cover the floor without cutting any tiles is 2 feet. Find the smallest positive integer divisible by each of the integers from 3 to 7. So the integers from 3 to 7 are 3, 4, 5, 6, and 7. So I want to get the smallest positive integer that can be divided by all of these. So I can multiply all of this in order to get an integer that's divisible by all of this too. But I don't know if I will get the smallest number, and I want to make sure there's not going to be a case where I'm like getting a number that's really big, but it can be smaller than that. So if you look at all of these numbers, so what you want to do is get rid of any numbers that might repeat. Like for example, you have a 6 here. 6 is a multiple of 3. So you know that any number that's divisible by 3 will be divisible by 6 anyway, so I don't have to multiply with the 6. And there's no other number like that here that will be a multiple of another number. So I'm going to do 3 times 4 times 5 times 7, and that gives me 12, 35. And if I multiply that, that will give me 420, and that is the answer we have right there. 3 runners begin running laps at the same time. Runner 1 completes 1 lap every 3 minutes, runner 2 completes 1 lap every 4 minutes, and runner 3 completes 1 lap every 6 minutes. How many laps does runner 1 complete before all 3 runners are once again at the starting line at the same time? Take a moment, pause this video, and see if you can get that answer. So in this problem, what you would do is find the least common multiple for each of the runners based on the amount of minutes it takes them. So the first runner takes 3 minutes, second runner 4 minutes, and third runner 6 minutes. And they said that we want to know how many laps does runner 1 complete before all 3 runners are once again at the same starting line. So that means you want to first find their common multiple of this number because these are minutes. So you want to see at 1 minute, does all of them have a multiple. So 3 has 3, 6. Continue 9, 12, 15. 4 has 4, 8, 12, 16. 6 has 6, 12, 18. So you notice that the least common multiple is this. So that means at 12 minutes, all of them are going to be at the start line. But remember, always make sure to see what the question is asking for, and they're asking for how many laps would have runner 1 complete before then. So at 12 minutes, runner 1 has completed 4 laps, so the answer is 4 laps. Download the SHSAT Prep app for iOS or Android for more practice.